Redox reactions, that's where this whole battery thing starts. I remember it with red and ox, shortened versions of reduce and oxidize, because humans are the absolute best at naming things. At least it's easy to remember. A lot runs on these reactions to you and your plant, but we've used it a lot in electricity. Without electricity, how could you microwave your toothpaste? That's right, you couldn't. Or I guess maybe, but then it would be much more complicated than buying a machine and pressing a button or two. Batteries, on the other hand, means that you could do that stuff on the go, which my microwave can't. After some extensive research, I was filled with determination, and I got working on my many plans. Well, that is, until I read the rules. In this reaction, we see with this small copper plate and this galvanized nail, we create a simple battery with a potato using the zinc and the copper with a voltage of 0.537 millivolts.
Immediately raise the question to if their name is like, 50.
For this chapter and project, I actually believe that batteries solely stored energy instead of making it. So before this lesson explaining it, the potato confused me, but no more.
You let me know when you're finished with that.
I decided to make a lead sulfuric acid battery because I found some spare sulfuric acid. Who knew they just kept that stuff in a little black box inside of cars? Anyways, I needed a way to make this battery, so I turned to my true friend, the internet. As I needed lead for this battery, I looked for sources of lead. Why is it all lead poisoning? Until giving up and asking my dad for help. Turns out he actually had some spare tin lead solder. In my first attempt, I didn't oxidize my lead, so I got sad results. With an okay voltage of 250 millivolts, but an amperage of, get this, 10 milliamps. The problem here was easy to spot, but fixing it was a different story. With this, I need to oxidize my lead, so I can run the reaction. I had two options here. I could either pour water over the solder and wait days for it to rust, or I could do something else. I know that solder, when soldered, smolders and smelts down to an oxidized form, but I didn't know why. I looked into it, and because, like all metals, when it starts melting down, it's easier to oxidize. I started having flashbacks to all these blacksmithing videos where I've seen them sprinkle on flux dust on the molten metal, making the flux super hot.
Keep it safe, I'm gonna use some flux on this.
Which apparently makes it super reducing, which takes the oxygen from the metal and from the air, preventing it from oxidizing. The solder itself actually had a pine resin flux in it, which means that whenever I heated it up and separated it from the flux, I got the oxidized lead that I needed. With the oxidized lead, I try at my second attempt, and with it, get higher numbers. I got a voltage of 250 millivolts, but it got as high as the high 700s, with 400 milliamps as an almost constant. I tried once again and got a constant of 300 millivolts, once again jumping to the high 700s. But my amperage jumped up to 700, and it occasionally wavered up to 900 in milliamps. The first attempt I mentioned was multi-celled. My batteries, for some odd reason, jumped in amperage a lot, but not voltage. If you remember, my potato battery had a much higher constant voltage, so I tried to find out why. I looked and found on my friend the internet, after such a long time of not using the acid, it can work less. And my bottle of acid is about a year old since when I got it. And I don't know how old it is, how old it was on the shelf. I'm assuming because it wasn't 100% seal, it grew stale. With the water that could have gotten in, and with the evaporation, it went through in this hot climate. So just a bit of an editor's note, I'm, finishing up the final scenes and putting together the last, bits, and I'm just editing at this point. And I decided to take a look at my sulfuric acid, bottle here. And I decided to look specifically at this part. It's pretty worn down, so I couldn't read most of it. But, the expiration date was 9 months ago. So that's probably why I'm having all the problems with the voltage. So, my bad. Anyways, just getting back to our normal thing, here's my conclusion. This helped me immensely, as before I honestly thought that batteries functioned like capacitors and stored nothing but plasma. My basic understanding was the plasma ball was basically this really low powered battery that because the glass was conductive, it could do the plasma ball thing. Redox reactions helped me so much understand how some batteries can't recharge and why so many do. I learned outside the redox reaction how small mistakes add up. I had issues with the mixture, not realizing that the sulfuric acid was already mixed with water as a battery acid replacement, and how to place the leads and how I should melt and solder every single piece. I had some issues trying to figure out how the multimeter worked too, and what I needed to do with it. I learned how people try to make designs as simple as possible, and how they can get complex just trying to get around the mistakes, like I had to do with my designs, even though it's really simple already. I also learned how to video edit, and how hard it can be to putting this video presentation together. Overall, this was an amazing final project, and I enjoyed it a lot. Thank you. What I really learned was that I never want to be in a situation where I have to rely on my batteries, because they were something to be desired. Time to check my potatoes. Oh, okay. Got that. Oh.